Students, and welcome to the continuing lesson on the wonderful world of parallel lines and transversals. And we're going to go on with another theorem here. And all these, there's several theorems here. You can see there's like 3 or 4 of them. And the idea is not to get too overwhelmed with them because they're really saying some very similar statements. Okay, they're saying something about parallel lines and the result of having parallel lines. So let's read this one. It says, if 2 parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So you got some lines here, and just to mix it up, I'll make it a little bit slanted. And then we got some transversal that cuts through here. So we'll call this L1 again and L2. Okay. And I'll number this the same way as I did before. So this is really saying, like, if the 2 lines are parallel, L1 is parallel to L2, then, and we have to identify what are alternate exterior angles. Well, in this case, it's 1 and 7, and then 2 and 8. So angle 1 is congruent to angle 7. Angle 2 is congruent to angle 8. Okay, that's what this theorem is saying. And here, I'm not going to prove this. You should try and prove this one on your own because it's very similar to the previous proof that was done up here in the previous video. So take a look at that one as a way to help you with it. But this is really what the theorem is saying. Okay, that if you have alternate exterior angles and parallel lines, then the alternate exterior angles are also congruent. Alright, so we're going to go on and look at the proof of Theorem 3.3, consecutive interior angles theorem. So I'm going to use the same picture as up here. Okay, so I'm going to use the exact same pictures. So if 2 lines are cut by a transversal, the lines are parallel, then the consecutive interior angles are supplementary. So all kinds of vocabulary word here. You have to make sure you know what all this means. So let's start with the hypothesis. If the first line is parallel to the second line, then consecutive interior, so that would be 4 and 5, okay, are supplementary. And supplementary, remembers, means that it adds up to 180 degrees. So measure of angle 4 plus 5 is 180. And then the measure of angle 3 plus 6 is also 180. Now we don't have to prove both of these statements. I'm just writing them out here so that you can see that both of these are in fact true. So the proof follows like this. Okay. So we're trying to show, I'm going to show this part, to show that 4 plus 5 is equal to 180 degrees. These are going to be my statements, and over here, my reasons. And again, the hypothesis is the given part. So L1 is parallel to L2. That's given. 2, because this is a statement about angles that add up to 180, I'm gonna pick angle 4. Okay, I'm just gonna pick angle 4 here, and I'm gonna show. If you can see from the picture here, 3 and 4 form a linear pair. They form this straight line here. So they have to be 180 degrees. So I'm going to say measure of angle 3 plus the measure of angle 4 equals 180 degrees. And they form a linear pair. And that's my reasoning. Now then, I almost have what I want. We want to show 4 and 5 are equal to 180. We have here a statement that says 4 and 3 are equal to 180. So that suggests if we can only find some way to connect 3 and 5 together. If we can find some way to do that, then we have what we're looking for. So we're going to use actually a theorem from the previous video, and that says that angle 3 and angle 5 are alternate interior angles, so they have to be congruent whenever the lines are parallel. So I'm going to say in statement 3, angle 3 is equal to the measure of angle 5 because they are alternate, because of the alternate interior angles theorem. And now I have a statement of equality, so I'm just going to take statement 2 here and write almost the exact same thing. Measure of angle, leave this alone for a minute. So something plus the measure of angle 4 equals 180. Now it originally had measure of angle 3, but 3 and 5 are the same, so I can make the substitution and say measure of angle 5 plus the measure of angle 4 equals 180 degrees. And this is substitution. And now I'm done. This is essentially what we wanted to show, and we've shown that. Yes, I'll make this a little bit more clear. This is substitution using statement 2 and statement 3. So we take statements 2 and 3 and put them together, taking 5 and plugging it in for 3, we have this one. So there you have it. This is a proof of the consecutive interior angles theorem. Continue to practice doing your proofs. Don't worry if they're a little bit tough. You may get frustrated. You may hit a dead end, but that's okay. All good mathematicians, all people who work on mathematics end up getting stuck at some point. Being able to power through them to continue working is, the sign of successful mathematicians and people who study mathematics. As always, ask for help if you need it. Thank you for watching, and have a wonderful day.